National Capital Region Transport Corporation, is mandated for implementing the Regional Rapid Transit System project across the NCR of India. RRTS is a new, dedicated, high-speed, high-capacity, comfortable commuter service connecting regional nodes in NCR. The elevated portion of the RRTS in Delhi is around 9.2 kilometers. It starts from Millennium Park and ends around Ghazipur Drain near Kondali, where the rail goes underground. During the construction of the elevated portion, NCRTC faced a lot of challenges including finalization of Sarai Kale Khan RRTS station to provide optimum multimodal integration. The Sarai Kale Khan RRTS station is situated on the Mahatma Gandhi Marg next to Sarai Kale Khan ISPT. The station was strategically located so as to provide the best possible integration with the existing model of transport, namely, Hazrat Nizamuddin Railway Station, Sarai Kale Khan Metro Station, and Sarai Kale Khan ISPT. The pedestrian skywalk is proposed in a way to provide safe and shortest path for interchanging mode of transport for the passengers. Before the construction of Sarai Kale Khan station, multiple sheds were identified and demolished, and a few structures like rain basera, public toilets, shops, transformers, dustbins, etc. were identified and relocated around the complex area. The enforcement yard was also relocated to accommodate the structure of the station. The elevated corridor goes above an existing underground tunnel of the Delhi Metro. Here the corridor was supported by several portal beams on two columns placed strategically around the tunnel to avoid infringement of the foundation pier with the tunnel. One of the piles of the foundation is as close as 1800 mm from the DMRC tunnel. During the pre-construction stage, multiple utility lines running under the proposed station were identified, including 1500, 800 and 300 mm water pipelines, and 220 kV, 33 kV and 11 kV electrical lines. The 1500 water pipe was not disturbed by strategically planning the support pillars, whereas the rest of the utility lines were shifted. The pile of the foundation goes as deep as 50 meters in this location. The traffic was also diverted to avoid traffic congestion in and around the construction site. The viaduct of the RRTS crosses over the automated driving test center, where a new portion of a test track was built in the test center to facilitate the support pier infringing with the old test track. Moving further down, the elevated viaduct passes on top of the existing Barapula flyover, because of which the height of the viaduct in this portion ranges from 24 meters to 19 meters. Due to the lack of space for the support pier around this area, a span of around 265 meters was constructed in cantilever using foam traveler at such height. Before the construction of this section, 220 kilowatt electricity lines were raised higher to avoid its infringement with the viaduct during construction. Here the foundation of Pier 58 was infringing with 5 major pipelines. These pipelines were laid in a very crisscross manner which made it difficult and more challenging to divert. In a very limited corridor space, 4 pipelines were accommodated and a new bridge was also constructed to divert some of the pipelines. During the construction of this portion, the cantilever hanging basket formwork method was used, keeping safety and traffic in mind. A portion of the elevated corridor also crosses Yamuna River, where the well foundation technique was adopted, and to complete the portion in a time-bound manner, launchers were used to construct the viaduct. During the construction of this stretch, a few challenges were faced. Some wells were not sinking properly, so divers were used to excavate the earth to facilitate the well. During the monsoon, Yamuna got flooded, because of which the construction of the viaduct became challenging. At another location, the elevated RRTS corridor crosses above an existing elevated metro station. Here the viaduct was supported by portal beams on 2 columns to avoid infringement. Moving further, the Ashoknagar RRTS station is constructed on single piers due to the unavailability of space because of the underground Kale gas pipelines passing near the station. Cantilever shuttering was used at this location because canals on either side provided inadequate space for shuttering. Also, a steel structure of 360 meters span was constructed due to the unavailability of land to facilitate the elevated corridor over Hindon Canal and Ghazipur Drain. In this section, pier number 272 was constructed near a 33 kV junction point, thus requiring more safety measures to avoid accidents. Construction of pier number 274 was a challenge, as it was positioned in the center of the road. Pier number 276 was closed to a water pipeline. Because of this, very little space was available for the construction of this pier. A portion of the steel span passes under a 220 kV electricity line, where strategic shutdown were made during construction. After crossing the steel span structure, the RRTS goes underground.